let's have a quick chat while they figure out the tech.
Yeah, so I think the first thing I'd think about, GeoDNet provides this hyper precise location. So we can locate you to using the base station network that's been built with deep-in principles. Now, pretty much anywhere in North America and in Europe, we can locate you to 1 centimeter in X, Y, and Z. And so a lot of people, the first thing they think is like, why is that even useful? Like, why would I ever need to locate with such high accuracy? And I think one thing to think about is, how do you feel when you're lost? Like when you're lost, you feel pretty terrible. You feel like kind of stupid, right? So I think that's the thing about how your robot feels when it's lost. So robots really want to know where they are to be able to do the things. You want this robot to do all this automated stuff. It needs to know where it is, and it needs to be able to map things as well. So GeoDNet gets used a ton in robots and drones, and it's really a super powerful use case that's emerging and is growing. The sensor technology is there, compute technology there, the needs are there, whether it's reducing labor, whether it's new government regulations, whether it's just the fact that that it's safer, that it's quicker, that makes your life better, right? And now the cost of the hardware is there. So we really do see, like I've been working in sensors my whole career for over 20, longer than I'd like to admit, a long time, building sensors for automotive, for aviation, for drones. And it's really right now, just the use cases and deployments of robots and drones, aerial robots is just exploding. And I think deep-in is just these things need these deep-in services like no tomorrow. Like one of the major challenges in deploying robots is the infrastructure required, the training required. Think about Waymo. They're in 3 cities. They just raised about $10 billion in the last 2 years since they spun out of Google. Spending $10 billion to run robotic vehicles in 3 cities. How's that if I take that robotic vehicle and I move it to Bangalore, it's going to need all new training, all new mapping data. So deep-in is really the real fuel to scale the robotic revolution. And so it is a really exciting time in the space, indeed.
Yeah. Yeah, Mike, I think we're good to go. But for example, I think GeoDNet is one of those examples where if you guys were, or if not you, but if somebody were to build like the same services as you guys in a Web 2, it would be completely prohibitive. So it's one of those use cases where deep-in really is providing a service that cannot otherwise be matched by a Web 2 counterpart. For those of you who are not aware, by the way. But anyway, Mike, please take it away. And yeah, thank you.
Thanks. Yeah, I'll just add on that point that actually in our industry, in this geospatial GPS industry, people have been trying to solve the problem that GeoDNet's doing for 20 years. And they've been building small networks and fragmented networks, coverage here, coverage there. And it just hasn't worked. And so what we've been able to do, and I'll show you just a couple quick slides. I don't want to bore you with a bunch of slides, but what we've been able to do by harnessing the collective power of blockchain and the deep-in community is solve a problem in about 2.5 years that the industry has been working on 20 years. And when you look at our YouTube channel, you can see a lot of interviews with customers. You'll see in these interviews, the customers are thanking us. They're thanking the community because it's enabling their businesses to succeed in a way that they hadn't before. And I think that's a really powerful testament to what this whole deep-in thing can do. I wanted to give, since hyper-precise location is probably something I understand you don't think about every day, but this video here, if I can get it to play, yep, here we go, just kind of give you an example of what's different between GeoDNet and GPS. So GPS is the purple line and GeoDNet is the blue line. The little device on top of the robot is a device that picks up the GeoDNet signal. It's one of these guys, the GeoPulse, which is a very low cost device, $149. And we can demo it here. We have them. You can go walk outside and see how it works. But you can see from a robot perspective, being able to navigate the world, being able to do the things you want it to do. The blue line is really what you want. You don't want the purple line. And that's, to do that, you have to have pretty massive infrastructure to be able to do this in a global way. To be able to provide that capability in a global way, you need to have a ton of infrastructure. And the way we've built that infrastructure is through what we call satellite mining, but it's essentially people buying and putting up GeoDNet certified reference stations all over the world, and then earning GeoD tokens as part of that process. And so it's as simple as the slide says. You get a base station. You should first look, because now there are a lot of stations out there. There are well over 10,000. I think probably 14,000 now have been registered on the network. So there are a lot of places like here in Denver where there are already a ton of stations, but you find an empty hex, ideally, if you want to get the maximum geode rewards. You install the station, connect it to the internet, and now you're providing precise location for all the robots in the same area. And one station can power as many devices, as many phones, cars, planes, drones, robots as you want. So it's a very nice tokenomic model, and that we just need to build this coverage out sort of one time, and then you have this hyper precise location available to everyone who wants to use it. And that we've done. So the network is now the world's largest hyper-precise network by quite some margin. We've kind of lapped the Web 2 competitors who've been working on this for many years, and made it available at really affordable prices to everyone, from people in the traditional industries like construction and survey to farmers, but also to all these new classes of devices like drones and robots, where we think there's going to be tremendous growth. This kind of gives you an example of the coverage map, where you can get 10 centimeter accuracy, where you can get 2 centimeter accuracy. And so there's still a lot of the world that needs to add, and we're working on thinking of ways to improve coverage in Latin America, Africa, and others. But overall, I mean, it's US and Europe are in really good shape coverage-wise, and that's helping power our business. You can sort of see the kind of important thing to take away from this slide is just that this is kind of the biggest company for high precision geospatial services in the US. This is kind of the biggest company in the world for high precision geospatial services for the rest of the world. They each have networks of about 5,000 stations. We're obviously a much bigger network now, much better coverage. We have customers tell us all the time the best vertical accuracy they've ever seen, the fastest convergence they've ever seen. So really, really performant network. And we're at the very, very early stages of the revenue growth. So we do have quite a bit of revenue on chain and to sort of deepen world speak, but actually it's just, we have a huge growth ahead of us as a project. And we've signed up a lot of customers. We announced a new customer today, Drone Deploy. Drone Deploy is the largest provider of aerial photogrammetry services and software in the world. They've raised 150 million in VC. They're doing multiple thousands of drone flights a week on the GEODNET network, all throughout North America and Europe. So super fast launch with that customer. And you'll see a video with us and the customer. But a lot of other areas besides drones, like agricultural robotics, normal precision farming applications, robotic mowers. I'll show you one of those in a second. All the different companies that make the GPS chips are starting to integrate GEODNET as a service directly into the chip architecture. And then we've been working with a number of Web3 protocols now. So we've started to extend this reach of providing this hyper-precise location into other types of Web3 applications, including Rover, who's here today. They're doing actually HD mapping data collection. So they're building the HD map of the world like you see when you see the Google cars driving around, or you see these autonomous startups like Neuro or Kodiak or Torque in trucking, or Aurora in trucking. They're out there trying to build HD maps. Well, the rover's using GEODNET plus a LiDAR system that they've developed to build that same data product through the Deepen model. And I believe that's going to be extremely successful, because the cost of doing this is just orders of magnitude lower, and the time is also so much quicker. And the time buys you a couple of big benefits as well. You get a lot more uniformity in your stations. You get a much more consistent network. And you're obviously not spending the CapEx. And then that's also allowing you to reach into communities and places that before maybe weren't worth it for the centralized company to deploy. You're able to get coverage into those regions very quickly, very effectively, and then that improves the quality of life for the folks that are using that. We see that in ag all the time, that people are like, man, I couldn't do this before. I couldn't afford it before. Now I can go toe to toe with the guys who are running the big John Deere machines, because now I can get the signal at an affordable price. And that's actually been noted by even the USDA, and they've started to run a GEODNET node and help us kind of promote precision farming services to the 2/3 of farmers in the United States that aren't on to precision farming yet. Actually, only 1/3 of farmers in the US today do precision farming. We have a very simple tokenomic model. I won't dive into it too much here, but there's a burn mint equilibrium model. We do use 80% of data revenue that comes in is used to buy back and burn tokens. And when we burn, we actually reduce the total supply. So it's a very strong deflationary model. We have an annual halving, and that, I think, very consistent, simple, easy to understand tokenomics is done very well by GEODNET. And yeah, so I wanted to hope you guys get a chance to see this GeoPulse device in action. It's pretty unique to actually see what centimeter accurate location looks like. You'll be able to take the device out, walk around in a pattern, write your name, whatever, and you'll see, you'll be able to see that just transcribed onto the surface of the earth. It's kind of cool. And there's a whole family of different products and services now using it in the Web3 world, a robotic mower, the GeoPulse. We also have this really cool partnership with Wingbits, which is another Web3 protocol. And we have one of the Wingbits devices here where you're able to mine GeoDNet, but you're also able to do ADSB. So ADSB is how we track planes, and Wingbits is a deepened network that's building out new ADSB tracking infrastructure. Very important stuff. It's one of these interesting cases where ADSB networks today are primarily run by hobbyists, but they are an integral part of the air traffic system. And there are places with poor coverage, and that's pretty crazy. If you looked yesterday, there was this close call at Midway. I don't know if everyone saw the news where basically a Southwest flight was on approach into the runway, and a private jet pilot ignored the tower orders. He pulled out into the runway, active runway. And luckily, the Southwest pilot just pulled up in time to not plow into the business jet. All the data that the news reporting shown is all ADSB logs. And so all that data is coming off of ADSB. There's a need for a lot more ADSB infrastructure to provide support to air traffic. And then there's also going to be a huge need for drone tracking. So the FAA has come up with a system for drone tracking that is it's a long story, but Wingbits will be able to track that data as well and provide the first kind of comprehensive drone tracking network around the world. So it's really exciting times to be in DeepIn. I think we're really seeing the second generation of protocols, kind of like GeoDNet and others in the room here, figure out how to actually monetize quickly and grow real businesses on top of it. And I think that's a huge thing for the crypto industry in general. So I hope to see it improve kind of the quality of crypto projects and create more support within Web 2 for using crypto rails and purchasing and using crypto services. And we have a big list of investors that have helped us get where we're at. We announced yesterday actually some funding from Multicoin, Parify, and DACM. So I think the project is on sturdy ground, and we're really looking to continue to grow our presence in robotics and drones using the DeepIn principles.